Hi, and welcome to the second tutorial in this series for 3D modeling in FormZ. In the last tutorial, we learned how to make some geometric looking shapes, and today we'll be learning tools like the Revolve tool to make some more organic looking shapes. By the end of today's lesson, you'll know how to export your file and be fully prepared for 3D printing. What you want to do is go up here to File, choose Project Settings, and make sure that you've selected under Data Scale, you want to select Miniature Watch, because we're making something closer to the size of a watch than we are to a building. Make sure it's in millimeters, and then we click OK. Since we're creating a revolved form and we need to draw a profile, it's easiest to understand the perspective of this profile from a left or right view. So I'm going to click up here and select the left view. To make our bars form, first of all, we're going to draw a 2D vector line. As I mentioned earlier, the great thing about FormZ is that it allows you to change the style of drawing tool in the middle of drawing. So first of all, we come over here to our drawing tools. We select the vector line. I'm going to use a straight line for the base of our bars. So we choose a straight line tool and we click at the bottom here and draw it out for the base and maybe up a little way. And then you want to change tool to the point spline tool so that we can make a curve. And then you can just sort of click around and make the 2D perspective of a vase that you find aesthetically pleasing, and press E to end the line. I should mention that when you're drawing, make sure that your tool options are set to 2D by clicking here. You can grab the top of that toolbar and pull it out to continue using it. Next, we need to give this line some thickness. If we were to just revolve this line, we would end up with a solid form, but we want to create a vessel. So we need to give some wall thickness to this 2D line. In order to do that, we come over to this tool here. We select from the Derive tool, we select the 2D option. And we come over here and we select a thickness, let's say 3 millimeters. We press Enter and then click on the line. Now it has some thickness. You see the yellow dots that we have here? These allow you to live edit the line that you've drawn to achieve a shape that you find more desirable. At any time, if you can't find these dots on your line, you can come to the Pick tool and select the line. To evoke those dots again, we right click, scroll down to Show Controls, and there they are again. So at any time you can re-edit your line by using those control points. Now that we have a thickened profile, we want to come over to the Derive To menu in order to revolve it. So click on Derive To and click Revolve, and then we have to look up the top here for instructions about what to do next. So it says to choose, select your source shape, which is our line. So we select that line, and then it asks us to select the axis of rotation, which is the Z-axis. We click that, and now we have a revolved form. In some programs this is called turning or lathing, but in this program it's called Revolve. So now that we have our revolved form, we can use this tool to scroll around and check it out. The key thing about this is that when you draw your 2D shape, you want to make sure that initially your line doesn't cross over the Z-axis, otherwise it won't revolve correctly. If it does, you can come over here and select your Move tool down on the bottom left-hand corner and just move it across so that it touches the blue Z-axis line but doesn't go across it. It's good to note here that we can still access those live edit points that we had before, which allow us to move and shape the 3D object that we have now, which is pretty cool. So you can continue to play with those until you have a vessel shape you're really happy with. One thing I want to show you is another way to edit your 3D object, and this is by pulling up your objects palette here, and we're going to revive the ghost of our thicken line and just hide this initial object, and then click on the ghost of our thicken line, which is the second one along there. There it is. And now we can edit that line to achieve a different 3D object. Within our pick tool, from the topological levels, we can select the line segment, and I just want to select the top segment here. Our vessel ended up with a flat lip, which didn't look so good on the top there, so we'll just delete that flat line. And now I'm going to choose the point spline tool to draw a round line on the top here. So first of all, we connect to the last point there, and just click away along to a semicircle that we're pleased with, and connect up with the last object, and you can still live edit that with the points that are there till you've got something you're happy with. And then once again we can choose to now revolve that line. So we come to the derive tool, select our object and revolve, and if we toggle around you can see now it's got a nice rounded lip on the top of the vessel there, which is much more pleasing. Now that we have our vessel, I just want to show you how the move tool works and how the active planes can influence the way the object moves or rotates in space depending on which plane you're on. So we'll drag that out there. So within the T-film tool you can click on the perpendicular view, because if you choose parallel it's hard to tell where you are in space. So we'll choose the perpendicular tool. So if we're on the XY axis, it will only move along the Z axis if we're in the XY plane. If we choose the next plane, when we're in the YZ plane, it will only move along the X axis. And the same again for the next view. And if we toggle the ZX active plane, it will only move along the Y axis, like that. Now that you've seen how the active planes influence the movement of the object, I also want to show you how they can rotate around that plane. So we select from the T-form tools, we select rotation. And again, the instructions at the top tell you what to do. So first of all, select the entity to rotate. That is our delightful pot. And then we define the center of rotation. Click that guy and drag out, and you can just rotate around that way. You can also manually enter the amount of degrees you would like to rotate your pot. Let's say 180. Click enter, and it's a round object, so it looks exactly the same. However, we can select this active plane down here by selecting the center of our object, drag out the rotation, and around it goes. Let's say 90 degrees, and we select enter. Lovely. We can do the same thing again around the other active plane. If you fancy, rotate around that guy. Same thing again, in the center, drag it out, round it goes. However, if you get stuck in an odd position like this, you can always press Command Z to go backwards. If you lose your plane or lose your object somewhere far away, you can press Command F to have it fit back comfortably in the screen. If something goes wrong, you can find it again. So 3mm is probably a good thickness for an object like this to print. It'll print really well in the 3D printer at about 3 mils. It's quite strong. And overall we want to keep our object to 80 by 80 millimeters. To know for sure how big our object is, we can use the measuring tool, which is conveniently shaped like a ruler down here on the bottom left hand side. You click that, you want to return to a left view so you can see the object side on, and just begin at the top and drag the ruler down to the bottom, and it indicates in the middle how big it is there. So it's 97 millimeters. So since we need it to be 80 by 80, we just want to shrink this down a little bit. So we come over here to the T-form tool, and you can select the U scale, which is short for uniform scale, and you can again follow the instructions in the top left hand corner of the screen. So it says, first of all, click the entity to scale, which is our vessel. So click in the center, and then it says once we've defined the center of the object, we click again outside here, and we drag it towards the center of the object to scale it down. And you can see in the top here with the measurements, you can either do this manually, or you can enter them in yourself. So we enter in 0.8 mils and click enter, and it will arrive at the exact size. And you can check this again with your ruler just to be sure. Now that we have our vessel ready to 3D print, we want to make sure that the object is mathematically sound so that it will go through to the printer. So to get this ready for export, we need to turn it into an STL file, and STL is short for stereolithic file. And this is a file format for 3D objects. It's very similar to, say, a PDF file, which is a very portable, very readable format along a lot of 3D programs, and is great for 3D printing. So to get it ready for that file format, we just need to run it through a little thing here called the doctor, which is found under the measure tools. There it is, the object doctor. And it will run a test through this object to make sure that everything is ready to go. Under the tool options for the object doctor, we want to select fix if possible as an action, and it will run through and try and fix any errors to make sure it's okay. So we select the object we want to doctor, and it gives you the results here. The length segments and faces and all of that has come up as 0, which means that's good. It's all sound, and we click OK. And now that is a great object to print. So now we are ready to export. We select our object with our pick tool. If you want to make sure on tool options that we're selecting the whole object and not a segment, click that sucker, and it's all red, so we know it's selected. We come up to File and scroll down to Export, and scroll down to, you see STL, and click on that guy. Now you might want to select an appropriate place to save your STL, maybe to the desktop, and you might want to make a new folder there to save your 3D STL files to. So my 3D files, okay, create, and then we need to name our vessel. Best way to do that is to save it with your student number and your surname so that we know who to give the object back to, and we say save. And it's run another couple of checks, and that's all good, and we click OK. The other thing you want to do is to save the raw FormZ file as well, because that allows you to come back in and continue to edit it and play with it. So we'll save that guy under your surname. You can save it in the same folder if you like, and we click save. And now that we have this blank canvas, we can import our STL file from before just to check that it's all good, it's all working. So we press OK, and there it is. Currently it's in the wire mesh view, but you can change the views up the top as we did in the last tutorial. to have a look. And it's been divided into all of those tiny triangular segments, which means that it's ready to communicate with the 3D printer. In the next tutorial, we'll also be looking at some more advanced operations in FormZ. These include ways to reshape, bend, and stretch different 3D objects through offsetting, pushing, and pulling. We'll also be looking at the Boolean operations, which is named after a mathematician. These include ways to union, intersect, or difference objects from one another. And you can slice them and stretch them, so we'll have a look at all of that in the next tutorial.